morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, I would like to explain how to design flange coupling. So already we have learned in previous sessions, so what are the rigid couplings and flexible couplings. And in this session, so design of flange coupling we will learn. So here shown the flange coupling the diagram. So mainly the flange coupling consists of two flanges. So here shown this is one flange and another flange is two. These two flanges are connected together with the help of bolt and nuts. So already you can see here nut and bolt. So what is the main purpose of this coupling? To join the two shafts. You see here shaft one end and another end. These two are joined, connected with the help of this coupling. This type of coupling is called as rigid coupling. These two flanges are connected with the help of bolt and nut. So in this main thing is how to design these flanges and bolts and how to calculate the shaft diameter we will see. In design of flange coupling, first we have to understand what are the components having that particular machine element, and then what are the forces acting on that, and then calculate stresses, and next step calculate the dimensions of each and every component. Clear? So we will see how to design. So these are the types of the flange coupling. Clear? First one is unprotected flange coupling, and second one is protected type flange coupling, and third one is marine type flange coupling. So these three types are classified as the flange flexible rigid coupling. Clear? So the flange coupling applications depends upon the type of load and depends upon the need of this coupling. See, the flange coupling usually applies to a coupling having two separate cast iron flanges. So already I told you. Each flange is mounted on the shaft. One end of the shaft, another flange is another end of the shaft, as shown in the figure in the first slide. And key to it, the faces are turned off at right angles to the axis of the shaft. For better connectivity, the faces of the shafts are turned off at right angles to the axis. Next one of the flanges has a projected portion, as shown in figure, and the other flange has a corresponding recess. Due to this helps to bring the shafts into line and maintain alignment with the other shaft axis. So that's why this type of flange coupling does not tolerate any misalignment. The two flanges are coupled together by means of bolt and nut. So this is the brief introduction about flange coupling. See, in this slide shown the flange coupling, the sectional views. Here, see, two shafts are there. This is one shaft and another shaft. One shaft and another shaft. And these two are connected with the help of this bolt and nut. These are bolts. This shaft is projected with this planes. Another shaft also, another planes. These two flanges, so the shaft and the two flanges are connected with the bolt and nut with the help of key. One shaft is having keyway to accommodate the key. So in this shown all dimensions of a flange coupling. Now have to calculate each and every dimension. First one, diameter. The diameter of the shaft. So already we have learned in design of shaft. So how to calculate the diameter of a shaft? On the basis of strength and on the basis of torsional rigidity. You have to use torsional equation. We will see while solving problem. Next, key. The key dimensions are, keys are two types, saddle key and Sankey key. You can use rectangular key, generally preferred Sankey keys. And then the flange dimensions. The flange dimensions are, see here, shown D1, D is equal to capital D is the diameter of the hub or outer portion of the planes, and small d is inner diameter of the planes or diameter of the shaft, and D2, D1 the pitch circle diameter, and thickness of the planes TF, and the length is 1.5 D. You can take directly 1.5 times of D. So all these values, dimensions you have to find out, and then finally draw a rough sketch of a flange coupling. Consider flange coupling as shown in figure. Here D is diameter of the shaft or inner diameter of hub. Capital D outer diameter of the hub, or D1 nominal or outside diameter of the bolt as shown in figure, and D diameter of the bolt circle, and N is number of bolts, and the TF thickness of flange. So, and other terms are toe base, toe B, toe K, allowable shear stress per shaft, shear stress per bolt, and key material. The shear stress, depends upon the material. It depends upon the shaft material, depends upon the bolt material and the key material. They will give in a problem. If not given, you have to assume. Next, tau C, allowable shear stress from the flange material, that is cast iron. Next, CB and CK, allowable crushing stress for bolt and key. In designing, finally, how to check for crushing strength, and you have to check for the shear strength. Toe base, toe B, toe K, allowable shear for shaft, bolt, and key material. Already I told you. So now we will see the design procedure step by step. First step is design for hub. How to calculate, how to design. So how to calculate the outer diameter of the hub and how to calculate the diameter of the shaft. See, the hub is designed by considering it as a hollow shaft. The hollow shaft conditions already you know. The area of hollow shaft. The hollow shaft is having two diameters. One is inside diameter and another one is outside diameter. It transmitting torque as that of hollow shaft. The hub is transmitting torque as that of a hollow shaft. So that's why use that condition. The torque T is equal to pi by 16 into tau C into D to the power of minus D small d to the power 4 by capital D. In case of the solid shaft, you can take directly pi by 16 into tau into D cube. But hub considered as a hollow shaft. Here tau C is allowable shear stress for the flange material, that is cast iron. Therefore, from the above relation, the induced shearing stress in the hub may be checked. The outer diameter of the hub is usually taken as twice the diameter of the shaft. As shown, capital D is equal to 2D. The length of the hub, 1.5 times of the D. If you know the diameter of the shaft, the remaining dimensions you can calculate. Here, check for allowable shear stress. The calculated stress is always should be less than the permissible value. Allowable shear stress only. Then only your design is safe. Next, second one, design for key. The material of key is usually the same as that of the shaft material. Here, shaft material is mild steel. The key material also same. The length of key is taken equal to the length of hub. So what is the length of the hub? Length of the hub is equal to 1.5 times of D. Here D is shaft diameter. Already we have calculated in the first step. So find out here length. And other dimensions of the key. What is the width and thickness? That is depends upon the type of key. It may be rectangular, it may be square. The key is designed with usual proportions and then checked for shearing and crushing stress. Here also checked for shearing and crushing stress. So already given that the crushing stress, the shear stress value. Next one, third step is design for planes. The planes at the junction of the hub is under shear while transmitting the torque. Here as shown figure, the dimensions of the planes given. So therefore, the torque transmitted. What is the torque transmitted? How to calculate? The circumference of hub multiply with thickness of the planes and the shear stress of the planes and the radius of hub. Here shown the equation, how to calculate the circumference of hub, pi d, and what is the thickness of the planes, Tf, as shown in figure, and the shear stress of the planes, tau c, and radius of the hub. So this is the equation empirical relation for calculating T. The thickness of flange is usually taken as half of the diameter of the shaft. The shaft diameter already you know. So you can take the thickness of the flange is 1 by 2 D times of D. D by 2. Therefore, from the above relation, the induced shearing stress in the planes may be checked whether it is safe or not. If not safe, again go back to first step and modify our dimensions. Next, design for bolts. In first step, hub calculation of dimensions are calculated, design of hub completed, and second one of the planes, key, and third one planes dimensions, fourth one design for bolts. How many bolts are required? What is the bolt size? The bolts are subjected to shear stress due to the torque transmitted. So the number of bolts depends upon the diameter of the shaft. And pitch circle diameter, as shown in figure, that is D1, there is a 3D, is taken as 3 times of the D. We know that load on each bolt is equal to pi by 4 area into stress. How do you calculate area? Pi by 4 into D1 square into tau B. What is the total load on all the bolts? If n number of bolts are there, then multiply with n. Suppose the number of bolts are 4, number of bolts are 6. So multiply with 6. You will get total load on all the bolts. So here shown the equation pi by 4 into D1 square into tau B into n. So now you can calculate torque transmitted. Pi by 4 into D1 square into tau B, multiply with n, load, multiply with radius, distance, D1 by 2. You will get torque. See, the final equation, the torque equation shown in this slide, T is equal to 5 by 4 into D1 square into tau B into n into D1 by 2. From this equation, the diameter of the bolt may be determined. Here you can calculate the diameter of the bolt D1. Now, the diameter of the bolt may be checked in crushing, whether it is safe or not. Crushing strength of the bolt. We know that the area resisting crushing of all the bolts N multiplied with D1 into TF. D1 is the diameter of the bolt, N is the number of bolts, and TF is the flange thickness. And the crushing strength of all the bolts, here shown the crushing strength. From this equation, the induced crushing stress in the bolts may be checked. So calculate the crushing strength of the bolt here. This value always should be less than the allowable crushing stress value. So then only your design is safe. So for that purpose, you have to check here the crushing strength and the shear strength. Clear? So like this, you have to design of a flange coupling. These are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.